Okay, worksheet 9.1 day 2. This is number 12. And again, like the other ones, I've got the sequence and then I have your answer right underneath it. And ultimately what you're doing here is this is one of the nicer ones where you don't actually have fractions, so you don't have to worry about what's in my numerator, what's in your denominator. The only other thing that I can kind of say is you start with a 3, but then if you notice every single one after that is a multiple of 5. Okay, so 5 might come into play, and so if you look at this, you're going to have a 3, and when you're doing this and you've got numbers like this, you almost want to look at factors. 3 times 1 gives me 3, and if I do a 3 times a 5, I'll get a 15. If I do a 3 times a 25, I will get a 75. If I do a 3 times a 125, I get 375, and so on. You do 3 times 625 to get 1875. And what you can see is that you have a 3 in every single one of them. So again, we look for things that are the same. And then you ultimately, even though it's not written that way, you do have a 5 in every single one of them because you can do 5, oops, let's go purple. 5 to the 0 power gives me 1. 5 to the first power gives me that 5 that I need. 5 squared, and then 5 cubed, and then 5 to the fourth power. And so what you can do is you can write your generic explicit, or your explicit formula for your generic term, I should say, so your nth term. So the 3 is there, the 5 is there, and then this is kind of like what we talked about in class. You're going to want to automatically just put an n there because you know that that's what's changing. Your exponent is changing, and your n represents what's changing. The only problem is we got to remember, guys, that this is for n greater than or equal to 1. So 1 has to be my first n, which means I have to plug a 1 right there, and that's not what I need for the first term. I need this to be a 0, so that's where the whole -1 comes in. Okay?